I'm Alan Pan, and I'm a science man. And today, we're going to be talking about atoms. What are atoms? Atoms are the fundamental building blocks of all matter. And matter's just about everything. It's galaxies and nebula, it's the air we breathe and the food we eat. It's your face. It's all made of atoms, all of it. Now, we could talk about atoms and subatomic particles, the particles that make up atoms, for days and days, but we don't have that much time. So we're going to stick to two main points. One, atoms are made of subatomic particles called protons, neutrons, and electrons. And secondly, atoms are mostly empty space. So let's get going. So, what does an atom look like? Well, the heart of every atom, dead in the center, is a structure called the nucleus. Now, a nucleus is made up of two different kinds of subatomic particles, protons and neutrons. A proton is a positively electrically charged particle, which means it will repel other positively charged particles but attract negatively charged particles. Now, if it helps, you can think of it almost like the poles of a magnet. Just like how north will repel north but attract south, electric charges are the same way. A positive electric charge will repel other positive electric charges, but it will attract negatively charged electric charges. Then we have the neutron. Neutrons, they don't have any charge at all, positive or negative. They're completely neutral. Neutral, neutrons. They're like the Switzerland of subatomic particles. Now, we got one more to talk about over here. This is an electron. As you can see, it's a tiny speck. It's way, way smaller than a proton or a neutron. Electrons exist on the outskirts of an atom, right on the outside, buzzing around the nucleus constantly. Now, this is the nucleus of a hydrogen atom. A hydrogen atom's nucleus is actually just one proton, no neutrons at all. The electron is kind of out here, and it's easy to imagine that it might follow kind of a circular or an oval path around the nucleus like this, almost like how Earth orbits the sun. But that is actually not the case. The truth is, electrons move completely randomly. They don't follow any path that we could trace. So if you took a snapshot of a hydrogen atom like this, at one moment you might see the electron here, but if you were to take another snapshot, it would appear instantly over here. And if you were to take successive snapshots like that, the electron would just appear to jump around completely at random. It's crazy. Now, after a while, you would start to notice a pattern. Even though this electron is basically teleporting around completely haphazardly, there is this sort of area where it's most likely to be. As you can see, it really exists in this ring. That's known as the electron cloud. Now, the electron cloud can have all sorts of weird shapes, but for the hydrogen atom it's pretty simple. It looks pretty much like this, where it's a fuzzy sphere around the nucleus. You can only describe an electron's travel by probability. Statistically speaking, where it's most likely to be, where it's probably going to be. You can't say for sure, ever, and that's pretty cool. Now, the one problem with this model here is that it's definitely not to scale. That brings us to our second point, which is atoms are mostly empty space. The distance between this outer electron and the nucleus is huge. So let's take a look at that over here. Now, the total distance across a hydrogen atom, its diameter, is about half of 1/1,000,000th of a meter. That's pretty small. But the nucleus of a hydrogen atom, the single proton in the middle, is about 1,000ths of 1/1,000,000th of a meter. It's about 30,300 times smaller. So the distance from the nucleus to the electron cloud where the electron is huge, and in between, there's nothing. So what does that mean, really? It's really difficult to visualize that sort of thing. I mean, do you know what something would look like if it was 30,300 times bigger than something else? Of course not. So that's why we have a visual aid of science. Now, suppose that this American dime was the proton, the nucleus, in the center of a hydrogen atom. It's about 1.8 centimeters across in diameter. That means its radius is about 0.9 centimeters. So what do you figure 0.9 centimeters times 30,300 is? Because that's where the electron is, distance-wise. So let's put this right here in front of Tommy Trojan at USC. Alright, Trojans, where do you think the electron is on campus if the proton of a hydrogen atom is right here? You think it's over here? Or maybe over here? Maybe it's even over here. Not even close. Let's go see where it is. About 225 odd meters away. More than the length of 2 American football fields. Right here. If you're a Trojan, you know that this is just right outside GFS. A little past the middle of it. So, there you go. You have about 5 trillion hydrogen atoms in your body alone. And in those atoms, about 99.999999999% of that is empty space. You are, by and large, mostly nothing. You're made of mostly nothingness. Your body is mostly the space between things. So I'm Alan Pan, the Science Man, and I hope you enjoyed our little talk about atoms. See ya!